Now we're going to do an example with rectilinear motion. So you can see here there's three plots. This first plot is for position, the second one is velocity, and the third one is acceleration. Now the equation of motion for the position is equal to x is equal to 2t cubed minus 24t plus 6. So this is telling us that our position x is a function of time because the function x is changing with respect to time. Now, when you look at these plots, it's really important to know that we are dealing with rectilinear motion. We only have an x value that's changing, so we have rectilinear motion, even though the plot has a curve to it. The plot doesn't look like a straight line. So what this plot is telling us is that at time is equal to 0, our initial position, so let's say we'll set an origin here at 0, and let's make a sort of our particle could move along this path, right? Because it can only move in the x direction. So this is our x direction. So it starts somewhere here at 6. That's where our particle is starting. But then you can see that our x is decreasing. So that means our particle is moving in this direction, and it moves all the way in the negative direction until it gets here, which looks to be about minus 25. So here it shows up, it's about minus 25 here where the particle stops in the negative direction, and then you can see it starts moving back up into the positive direction. So that means it's now moving back along this diagram all the way, and I didn't draw it long enough, but it goes all the way to something like about 40 over here. So the position of the vector starts positive, goes towards the origin, so it stays positive until it hits the origin, and then becomes negative, because as long as it's to the right of the origin, the position vector is going in the positive direction. Once the particle switches to be left of the origin, now our position vector would be going that way and would become a negative value. For the velocity, our velocity starts off as negative because our particle is getting closer to 0, so it's going from a larger number to a smaller number, and then it's actually increasing in the negative direction. So you can see our velocity starts off as negative, stays negative, and then at time is equal to 2, switches over to now our velocity is being positive. This point in time at 2 seconds coincides up here with the most negative point. So that's actually the turning point here where the particle goes from moving towards the negative to then moving towards the positive direction. The acceleration is actually positive the whole time. You see the acceleration starts here at 0 and is increasing the entire time. And that's because even though the particle is moving in the negative direction, its velocity is becoming less negative during that time. And so the acceleration is actually positive. So when you see these position, velocity, acceleration graphs, it's really important to look at the values and understand what's happening really well. So for this question, the first question that this problem asks us, and we don't actually need the graphs for a little bit. The first question is A, determine the velocity and acceleration as a function of time. So the problem gave us x as a function of time, which was equal to 2t cubed minus 24t plus 6. Now, the notation in the question didn't include this, but you can always write it out that way if you want. So the velocity is going to be dx with respect to time. So it's just the first derivative of the position, which will be 6t squared minus 24. The acceleration is equal to dv over dt, which is now the derivative of this equation. So then the acceleration is equal to 12t. The second question asks us the time at which velocity is 0. The time at which velocity is 0. Now for this question, all we have to do is look at our velocity equation. Velocity is equal to 6t squared minus 24. Set that equal to 0. So then we have 6t squared equals 24. T is equal to 2 seconds. Time can never be negative. We're never going to be going back in time in this course. Now for C, the question asks us the position and acceleration when velocity equals 0. So position and acceleration when velocity equals 0. So when velocity equals 0, we know that time is equal to 2. So this question is also saying position and acceleration when time is equal to 2 seconds. And we have equations. We know our x is equal to 2t cubed minus 24t plus 6. So all we have to do is plug 2 here, plug 2 here. We end up with x is equal to negative 26 meters. And we have acceleration is equal to 12t. So we plug 2 in here, which would be equal to 24 meters per second squared. So now if we go back to our graphs, we can see that when time is equal to 2 seconds, our position here is at minus 24, which is what we guessed from originally. Our velocity is equal to 0, and our acceleration is equal to 24 here. So you could find them from the graphs, but you can also find them mathematically using these equations. Now the next question is asking us the net displacement and total distance traveled from t equals 1 second to t equals 4 seconds. Now this question you have to be a little bit more careful of. And I'm going to show you, I'm going to go back up to these graphs here. Because when time is equal to 1 second, we are looking at this moment here. And when time is equal to 4 seconds, we're looking at this moment here. The particle is moving in the negative direction for t equals 1 to 2 seconds, and then it's moving in the positive direction from t equals 2 seconds to 4 seconds. So that would be this piece here and this piece here. So if we're looking for the distance traveled, we're going to be looking at the sum of the magnitudes of the piece when it's moving in the negative direction, and then the distance traveled in the positive direction. And then when we're looking for the net displacement, we're just going to do a vector sum of displacements. So let's do the math of that. So this looks like, so it moves in negative direction from t equals 1 second to t equals 2 seconds, and the positive direction from t equals 2 seconds to t equals 4 seconds. So we'll actually solve what the position vector is at 3 points. So first we'll look at x at 4 seconds, or I'll just say x4, we know that the unit is time. X at 4 is equal to 2 times 4 cubed minus 24 times 4 plus 6 is equal to 38 meters. So that's the position of x at t equals 4 seconds. The position of x at t equals 2 seconds means we just replace time with 2 seconds. We end up with a value of minus 26 meters, which we already knew from the previous question. And then x at 1 second will be equal to minus 16 meters. So for the total distance traveled, we'll do minus 26 minus negative 16 absolute value. So that's the distance traveled in that negative direction plus 38 minus negative 26 absolute value. This is equal to 10 plus 64, which equals 74 meters total distance traveled. If we want just the net displacement is just the distance, is just the delta, the change in position vector from that first point to the second point. So the net displacement would be x at 4 minus x at 1, which is just equal to 38 minus negative 16, which is equal to 54 meters. And so from this problem you can see a little bit more clearly that the distance traveled is not equal to the displacement.